Okay, we're going to look at the vector assessment here that I've handed back to you. If you're trying to get points back for this, I suggest you watch this video and kind of follow this carefully. It says here that given the following points in 3D space, so they give you a three-dimensional point and three-dimensional point, it is known that the line L1 passes through point A and has a vector equation of this. So this is L1, and then there's another line L2 that passes through point B and has this vector equation. These two lines intersect at point T. Find the vector coordinates at point T. So basically, these two lines right here, these two right here are going to intersect. So we have to figure out when that's going to happen. So I'm going to write like this. I'm going to have -2, -2, 5 plus W times 4, 6, and 2. And this apparently will equal the other vector equation of the line, which is 6, -2, 1, plus P, which is a scalar, times 4, -6, and -6. Alright, so let's try this. Alright, so they want to find the coordinates of T, point T where they intersect. So I say, okay, let's take a look at this. We're going to create a system here. We have -2 plus 4W, so I'll write that, -2 plus 4W. And that's going to equal 6 plus 4P. So 6 plus 4P. Let's create another equation. Let's just use, I guess we could use the bottom. I don't think it really matters. 5 plus 2W is equal to 1 plus -6P, or 1 minus 6P. So we have a system of equations here. You can solve this by hand if you like, or you can use a calculator very quickly. Really doesn't matter. I'm going to try to solve for W and P by hand here. So let's take a look. Okay, this is what I'm going to do. I'm going to multiply this bottom equation by -2 is what I'm going to do actually. And this is going to give me -10 minus 4W is equal to -2 plus 12P. And I'll just copy this top equation over. So -2, 4W, sorry, 4W. That's a W. Ugh. And that's equal to 6 plus 4P. And I'll just add these together. -2 plus -10 is -12. These will eliminate. That's why this is called the elimination method. It's equal to 6 minus 2, which is 4. And then 4 and 12 make 16. P. That means that 16P will equal -16 when I subtract 4 from both sides, so P will equal -1. Alright. Now, if I really wanted to know W, I could plug in -1 into either one of these equations right here. So let's say if I make this P right here -1, this becomes 6 minus 4, which is 2. That means that -2 plus 4W will equal 2. Okay, so that means 4W will equal 4, and then W equals 1. That's what's going to happen, I believe, here. But anyway, I don't have to do that. I can just plug this right in here and figure out the 3 coordinates. So what I have is 6, and then this is -1 times 4, which is -4. And then I have -2 plus 6, and then 1 plus 6. These are going to be my 3 coordinates, which will give me 2, 4, and 7. This is the coordinate of point T, the intersection point. So here's the answer for this after I plug that back in. So here's the solution for point T. Find TB. Alright. Now that I have point T here, since this is point T, they want to find the vector TB. So basically what I'm going to do is take vector B, or point B, the vector equation for B, and subtract T from it. So they give me B right here though, which is nice. 6, -2, and 1, and then I'll subtract T, which is the thing I just found. This vector here, 2, 4, 7. Simple enough. So 6 minus 2 is 4. And -2 minus 4 is -6. And 1 minus 7 is also -6. So here's your answer for TB. This is the vector TB right here. Alright, point C is situated at the midpoint of TB. Find the vector coordinates of point C. So that's where point C is, at the midpoint of TB. So this is pretty easy. I actually now have to take all the coordinates of B add them to t, and then divide by 2. That's pretty much what I'm doing, every single one of them. All right, so I guess I really should say this is actually 1/2. Okay, 1/2 the vector b plus t is really what that is. All right, so let's take a look at this. B is, again, 6, -2, and 1. And then we're going to add the vector equation for t, and that will be 2, 4, 7, one we found in part A. So it's really this here, if you put it like that. So this will be 1/2 of 8, 2, and 8. So this answer will be 4, 1, and 4. That will be the midpoint. This is point C on TB. Okay. Alrighty. And let's try triangle. Triangle is formed with vertices points A, T, and C. Use a mathematical technique that you know to solve this triangle. So I want all the angles and all the side lengths. Okay, so that's actually not that hard. If we just kind of draw a triangle here, we'll sketch one. We don't really know what the triangle looks like in 3D space, so I'll just make it a 2D triangle and pretend it's a 3D triangle. So this will be A, T, and C. So what I have here is, actually, do I know a vector already? Yes, I do. Use something we already know, like TB. Well, we don't have TB, do we? But we do have, yeah, okay. So imagine I have a vector leaving A, and that's going to be the vector AT. And then I have another vector leaving A, and this will be AC. Alright, so what I'm going to do is basically find the vectors AT and AC, find their magnitudes, and that'll give me these two links here. And then I'll also create a third vector here. It doesn't particularly matter which one it is. We can just call it TC if you like. And then once I find the magnitudes of all three of these vectors, I'll have all the side links if you like. So let's do that. Let's find AT then. Vector AT is given by taking point T and subtracting point A. And we found from part B that T is 2, 4, 7. And point A, which is given to us at the top here, if you recall, is -2, -2, and 5. Alright, so we'll go ahead and do that. -2, -2, and 5. Very well. And this will give me 4, 6, and 7 minus 5, which is 2. Alright, so that's the vector AT. And then I'll have to find the magnitude of AT. So the magnitude of AT is the square root of all three of these squaring added together. Okay, so this will equal the square root of 16, 36, and 4. 4 and 16 and 20, so this is root 56. We'll just leave it as root 56. So I'm going to say this side length right here is root 56, really. And then we need to find AC as well, so let's go ahead and do that. AC. Alright, so let's take a look at where C was. That's that midpoint again. We found it right here actually. It's 4, 1, and 4. So we're going to take C minus A, which will be 4, 1, and 4, minus A, which we've now already seen is -2, -2, and 5. This will give you this vector, which is 6, 3, and -1. And then I'll take the magnitude of that, AC, which will be 6 squared plus 3 squared plus -1 squared. This will be square root of 36 plus 9 plus 1, which is now root 46. So root 46 is AC, so I'm going to say root 46 is right here. And let's find the third side length, TC, if you like. So vector TC, this one's a bit of a long-winded problem here. It's C minus t. Alright, so let's just go through this again. It's 414 minus 247, since we know that's 3t. And this will be 2, negative 3, and negative 3. So now we know that the magnitude of TC, this is a magnitude by the way, can be found by the square root of 2 squared plus negative 3 squared plus negative 3 squared again. That's 9 and 9 and 18 and 4. So this should be root 22 by the looks of things. So this will be root 22. Those are the side links. Those are all three of them. 1, 2, 3. That's a 56 there. Okay, so or you could just circle them right here once you get them. These are all three of those. Boom, boom, boom. All right. We need to actually also figure out these angles. There's a reason I did AT and AC deliberately here, because if I have these vectors leaving this point, AT and AC, I can actually find this angle using a dot product. Okay, and then I just have to do it one more time, and then I can get all the angles, because all the angles should add up to 180 in a triangle. So let's keep this going right here. We don't need all the space here to find the area right here, so I'm just going to keep using space here and see what happens. And let's extend this a little bit. Alright, so let's keep using space to do this. Now we're going to find a dot product of AT and AC. Okay, and that's going to equal the magnitude of AT times the magnitude of AC times the cosine of the angle between them. So this will help me find this angle between AC and AT right here, these two vectors. The dot product is pretty straightforward. Remember that I have AT and AC right here, so this is going to help me. This dot product can be found by doing this. It's going to be 4 times 6 plus 6 times 3 plus 2 times negative 1. That will be the dot product portion of this. This will be the left side of this right here. Okay, so this is going to be 24 plus 18 minus 2. All right, keep in mind that I'll give you 22 plus 18, which should be 40. Okay, so this will end up being 40. So that means that 40 is equal to the magnitude of AT, which we now know is root 56 up here. We already found this answer. And the magnitude of AC is root 46 times the cosine of the angle. Therefore, the angle will equal the cosine inverse of 40 over root 56 times root 46, and then we'll figure out what this is in the calculator. Okay, some angle like that. So let's go open the calculator. Okay, so we add a calculator, and we're going to go to trig cosine inverse control divide 40 over root 56 times root 46. And that angle will be about 38 degrees. 37.99 or 38 degrees is adequate for our purposes. So we'll say this is about 38 degrees. And that'll be this angle right here. 38 degrees right here. Okay. And then we need to find one more, and then we can find the third pretty easily. So let's find this one here. This was a poor choice to do this way, but that's okay. I really should have, let's do it this way, yeah. Okay, so we have this. I know TC, I have an angle TC, that's pretty straightforward. I have that as root 22. I mean, there's a magnitude here, but I need to find the reverse of AT. They need to be leaving this point here. So I need to go the opposite direction with AT. So all I really have to do is flip all the signs of AT, and then we can do another dot product. Okay, so this will give me the vector TA, which is the same thing as AT with all the signs flipped. So I need to do the vector TA dot product with the vector TC, which I already have, and then the magnitudes again of TA times TC. magnitudes times cosine of theta. Alright, so the dot product, let's get some space here. We know that up here that AT is 4, 6, and 2, so that means that TA will be -4, -6, and -2. Dot product with TC. I already know TC is 2, -3, -3 because I found it right here. And then we're going to do that. So this will give me -8 plus 18 and then plus 6 by the looks of things. Alright, so that's going to be 16 is really what that is. Alright, so what I'm going to say then is that 16 is going to equal the magnitude of TA, which is the same thing as AT, and the magnitude of AT is root 56, and the magnitude of TC is root 22 cosine of theta. So theta is equal to the cosine inverse of 16 over root 56 times root 22, and then this will give me the answer for that one. So let's find that. So cosine inverse, control divide, 16 over root 56 times root 22. And that'll be about 63 degrees, 62.89 we'll say. Okay. So we got one angle here, we got another angle. The third angle can be found because all angles must add up to 180 in a triangle. So we'll just figure that out with a calculator. So I'm going to hit Control negative, which gives my previous answer. I'm going to add that to 37.99, I guess, if you want. And that'll be that. So I'm going to take 180, and I'm going to subtract my answer there. And this will give me the third angle, which is about 79 degrees, 79.1 degrees. And that'll be the third one. So 79.1 degrees. These are the three angles in the triangle as well. Okay. So this one is 79.1 degrees, and this one, of course, will be it'll be about 62.89, I guess, right here, thereabouts. So that's all three of them. That's all interior angles and all side lengths. That's that answer. The area of a triangle ATC. The area of a triangle, pretty straightforward, is 1/2 the base times the height. Okay. So you could actually make this height anywhere you want, pretty much. And we know these angles, of course, so that's really nice. One thing I could do is I could say this base here is the magnitude of AC, and the magnitude of AC is root 46. So I could say area is 1/2 root 46. I have no idea what this height is, keep in mind, right? But I do know that the height over the magnitude of TC is actually the sine of this angle. Right, so what I'm going to say is this h right here. I'm going to say h over TC. TC's magnitude is equal to the sine of 79.1 degrees. Okay, so that means that if I simply multiply the magnitude of TC, which I know already is root 22, times the sine of 79.1 degrees, that will give me the actual area. It should be about 15 point something, I believe. Let's try it out. Okay. So we'll say 0.5 times, what is that, root 22. What was it? I forgot. Times root 46 times sine of 79. Okay. So we'll say that's times root 46. Oops. Times the sine of 79 degrees. 79.1 degrees. Which is that angle we just found right above there. Okay, this is going to be approximate, but very close. And it is about 15.6 square units here. So I'll do that here. 15.6 square units. Did I tell you lengths or distances or anything? No, I didn't. So I didn't tell you any units, so you can kind of make them up if you want. I'll just say units squared since I didn't specify. Okay, so that would be the area of that triangle. Seems like a lot of work, but this was, once you got to this point, the rest of it's actually kind of smooth sailing. This is probably the hardest question on the test easily. So let's switch this around. Let's go to the next page. Double the area you found in this part. All right, so basically what I want 2 times 15.6. All right, and that should be 31.2 units square about. Something around there you would have gotten credit for. Anything like this would have been okay. Find the area of a parallelogram formed with the sides TA and TC. Okay, what that really is going to give you is a parallelogram that's double the area of this triangle. Okay, so it really should be the same, but how you were intended, how is intended this question to be designed is so you do a cross product of TA and TC. A vector cross product. This is what you're supposed to demonstrate here in this question. Whether you did or not is okay, but this is what you were meant to do. So we need to find a cross product, and keep in mind we need to find the vector TA and the vector TC. And I think we already have that here. Let's go down and find it. So the vector TA, remember TA is just the same thing as AT with all the signs flipped, so it'll be -4, -6, and 2. And TC we have right here, which is 2, -3, and -3. All right. So let's go down here. This will be basically, we'll write it like this, as I, J, and K. And then we'll have -4, -6, -2, and then we'll get 2, -3, -3. I'm pretty sure that's what that said, right? Okay, so let's go ahead and figure this out. We're going to set up some determinants here. We're going to cover up this column and this top row, and basically we're just going to have this matrix right here. This is going to be -6, -2, -3, -3. That'll be your I component. And then we're going to do this. We're going to cover up the middle one and the top, so we'll have -4, -2, and 2 and -3. That will be your J component, and then we'll add the last one. We'll just cover this last column, so it'll be -4, -6, 2, and -3. I'm sorry, that's a +2 and -3. This will be your value for K. So to do determinant, we just multiply the diagonal and then subtract the product of the other side. So it's -6 times -3 minus -3 times -2. So -6 times -3, this will be 18. And then we're subtracting this product here, which is actually 6. Okay. And then we'll keep going. We'll say -4 times -3 is 12. Right here. And then we're subtracting a negative, right? We're subtracting a -4, which means we're adding 4. J. And then here we're going to have 12 again. And now we're subtracting a -12 right here. So we're going to add 12. Which is interesting, because if that actually happens, we got 12 and 12, which would make 24. Okay, so this will be 12i. And then we're subtracting this, remember, so this will be -16j, and then plus 24k. Now to find the area of a parallelogram, we just have to take the magnitude of this cross product. So we have to actually find the magnitude of TA. Oh, let's not put it like that. The magnitude of TA cross product with TC. We have to find the magnitude of this cross product. So basically we have to find the magnitude of this. So this magnitude is going to equal the square root of 12 squared plus -16 squared plus 24 squared. Okay, so let's use a calculator to figure out what that is. Okay, so we'll say the square root of 12 squared plus, let's go ahead and put in -16, although it wouldn't matter if it's positive or negative, and we'll say plus 24 squared. And this will equal 31.2, which is about what I expected it to be, because as you'll notice, that's actually the same, about the same as the answer I got right up here. Okay, it should have been the same about. So we're going to say that's about 31.2 square units again. And that's the area of the parallelogram. So it says compare your answers to this one and the one up above it. What do you see? They are the same. That's what you should have seen from this. They are the same. Okay. Number 2. Okay. See, all that was question 1. That was half the test. Was one question. Lots of parts to it, right? But here we are. Question 2. Let this and this. Okay, so v equals this and w equals this. The vector v plus scalar p times w is perpendicular to w. Find the value of p. Fair enough. All right. So let's go ahead and figure out what this is right here. I'm just going to write this. So we're going to say v plus pw is equal. Remember, v right here is 3, 4, and 1 plus a scalar times w, which is 1, 2, and negative 3. All right, and this will give me the vector 3 plus p and 4 plus 2p, and then 1 minus 3p. That's the vector v plus pw. If they tell me that this vector that I just found is perpendicular to w, that means their dot product we should say, equals 0 of these two vectors. So we need to find the dot product of this vector. Okay, we need to find the dot product of that vector. I have to write it all over again. 4 plus 2p, 1 minus 3p. And w itself, which is again 1, 2, and negative 3. This dot product should equal 0. Okay, so let's do this dot product. We got this times this, which is 3 plus p. And then we got this times this, which will be 8 plus 4p. And then we got negative 3 times this right here, okay, which is going to be negative 3 plus 9p. All this is equal to 0 if you add it all together, supposedly. So let's add the p's. We got 9, 4, and 1. That would be 14p. Oops, 14p. And then we got 3, 8, and negative 3. So this is just 8 equals 0. That means p is equal to negative 8 over 14. And most people will call that negative 4 over 7. So this is actually the answer for p that they ask you for. That's the answer right here. Or you could have put this. I would have given you credit for either one. And we move on. Number 3. In this question, the vector 1, 0, this is in kilometers, represents the displacement due east. Okay. And the vector 0, 1 represents a displacement due north. Okay, so 0, 1 means 1 kilometer north, and 1, 0 means 1 kilometer east. The diagram shows the path of the oil tanker, the Aristides, I guess we're going to pronounce that, relative to the port of Orto, which is situated at the origin 0, 0. Okay. The position of the Aristides is given by the vector equation at time t hours after noon. So find the position, so after 12. I guess we're assuming that's 12 noon. It could be 12 in the morning. So we'll see. Find the position of the Aristides at 1300 hours. Okay, so yeah, I was going to say this is noon then. All right, so if we're at 1300 hours and t's hours after 12, then t is going to be 1. Because at 1200 hours, if we add 1 hour to that, we're going to get 1300 hours. So we're going to take this value 1 and substitute it in here. That's all that really is, so it's pretty straightforward. We're going to say xy, the position, is going to be given by 0, 28, plus 1 times 6 and negative 8, which is basically 0 plus 6, which is 6, and 28 minus 8, which is 20. So this is actually the answer for this question, is 6 and 20. Okay, so it's 6 kilometers due east, 20 kilometers north, right? Together makes that vector. Okay. Alrighty, so what else are we doing here? Okay. Oh, for your reference here, 6 and 20, it's about like here. Yeah, somewhere over here. After 1 hour, it's going that way, just to give you an idea. All right, so the velocity vector. Okay, velocity vector, you need to pay attention here. The velocity, as you guys know from physics, is equal to the change in position over the change in time. Okay. Now, to find a position, I have to multiply both sides by time, or the change in time, right? The position will be time times velocity. And if you notice here, time is being multiplied by a vector, and this vector happens to be the velocity vector. For this reason, this is the velocity right here. This is the starting position, and this is the velocity times time, which gives you a position. So the velocity vector is simply written in this equation as 6 and -8. That is the velocity vector, okay? The speed of the Aristides is the magnitude of this velocity vector. So the speed is simply the magnitude of that vector, which is the square root of 6 squared plus -8 squared. So this is the square root of 36 and 64, which is the square root of 100. So we're going to say this guy is going 10 kilometers per hour, because the square root of 100 is 10. That's pretty much this answer. This is easy, okay? Find the Cartesian equation to represent the path of the Aristides in the form of ax plus by equals g. This is a standard form equation of a line. So let's take a look at this vector they give me, vector equation. What this really is here is a point, this right here. And this right here is the slope of the line written upside down. Okay, because here they're putting x over y, and the slope is a y over x. The actual slope is actually -8 over 6, which is in fact -4 over 3. This is the slope of the line, and the point on the line that they give me is 0.28. So let's take that into consideration. 0.28 is a point, and we know the slope. What did I say it was? -4/3. Okay, so we recognize the equation of a line from Algebra 1 as being mx plus b. We're going to plug this value into m. We're going to plug this value into y. We're going to plug this value into x. And we're going to figure out the unknown b. If I plug in 0 in for x, this doesn't really matter what the slope is. It's just b is going to be 28. b is 28, okay? Because we already know that because this x value is 0. That is obviously a y-intercept. So then now that I know this, I could write this equation as being -4/3 x plus 28. But now I have to convert it into a form that looks like this. I have to get x and y on the same side, and technically a and b cannot be anything but an integer. So I'm going to get rid of this fraction by multiplying this entire equation by 3. So this will give me 3y is equal to -4x, and then we got 3 times 28, that's 60, and 24, that's 84. Okay, and then I'm just going to move this 4x over here and change the sign, so it's going to be 4x plus 3y equals 84. So I got A, B, and C, or A, B, and G, and here's A, B, and G. This is technically the answer that they wanted for this question, okay? Alrighty, another ship, cargo vessel, the Boadicea. Alright, I guess we're just going to call it the Bode here, the Bodie. Is stationary. What position vector 18? With the position vector 18.4 kilometers. Okay. Show that the two ships will collide and find the time of collision. All right. Keep in mind that the first vessel had this thing going on. It starts at 0.28 and has a time t, and then I believe this was 6 and -8. This was going here. That was for the Aristides. If this is going to collide with this guy, all right, this vessel is stationary. It's not moving, okay? All I have to prove is that this is at some point going to equal 18 and 4, because this is where it's located, and this is a position here, this whole thing for this. So I just have to find a value for t where they're actually going to collide. This guy is not moving. This guy is moving, toward it. So let's figure out this then, what time this is going to happen. It's 6t plus 0, so we'll say 6t is equal to 18. All right, and apparently also that -8t plus 28 is equal to 4. It should be common sense by looking at this that t is going to be 3, because 6 times 3 is 18. So t is going to be 3 hours. Okay, and let's ensure this happens. If I plug this in here, this will be 3 times -8, which is -24, and keep in mind -24 plus 28 is 4. That's true. So if t is a number of hours after noon, what is 3 hours after noon? That'll be 1500 hours. That's when they're going to collide. Okay, in military time. So that's the time of the collision. It's 3 hours after the Aristides departs its position here. To avoid a collision, the body starts to move at 1300 hours and has this velocity vector here. Show the position of the body for t is greater than or equal to 1 is given by this. Okay. Alrighty, so as you can see here, this is the velocity vector, and they've given it to me right here. Okay, and they want this thing to move. Show the position is given by this. Okay, there's a couple ways we could do that. What I'm going to do, since it's moving at 1300, that means t is going to be 1. So I got this here. Okay, t is going to be 1. And I want to say that its position vector is here. Okay, its position vector is here. Its starting position vector. So I need to prove this is related to this for some value of t. So actually, let's use this here. I'm going to make this my xy. If I can prove, right, that if I multiply this by some scalar and add it to this, it'll equal 18 and 4. That'll be adequate. So this is what I'm going to tell you. It's where its starting point is 18 and 4. I'm going to say that's equal to 13, negative 8, and then plus some value of t times 5, 12. Okay, I'm going to get two equations out of this. If I get the same t value for both, then this is true. So I'm going to tell you that 5t plus 13 equals 18. And I'm also going to give you another equation that says 12t minus 8 equals 4. If the values for t for both of these is the same, then we're good to go. So we're going to say 12t. Let's add this to both sides. This will actually equal 12, so t will equal 1, which is something I pretty much already said right here. And this has to be 1 as well. So if t were 1, and I substitute 1 into here, then this becomes 5 plus 13, which is 18. And 18, of course, is equal to 18, so this is proven. This is true for 1 hour. This is okay. All right. Okie doke. So find out how far apart the ships are at 1500 hours. So what I'm going to do is I actually have to figure out the position of the Aristides at 1500 hours and the position of the Bodhi at 1500 hours and figure out a vector between their two positions and find its magnitude. This is kind of interesting, but it's not that hard. What I'm going to do is plug in, let's see, this thing starts to move at 1300 hours, okay? So it's important to understand that if it's moving at 1300 hours, to get to 1500 hours, this value for t is only going to be what? It's only going to be 2, because after 2 hours, okay, it's going to be at 1500 hours right there, because it's starting at 1300 hours. So let's actually figure out where this position is first. So the Bodhi is going to have a position of xy, and this is going to equal 13, negative 8, and this is going to be plus 2 times 5 and 12. And this will be given by 2 times 5, which is 10. This will be 23. And then 24 minus 8, which should be 16. So we're going to say 2316 is where this ship is going to be at 1500 hours. This is important. I have to find the location of the Aristides as well. So that one again was given as 0.28. To get to 1500 hours, remember this is 3 hours for that ship because it's starting an hour earlier than the other one. So this is going to be 3 hours, and that was 6 and negative 8. So this is going to give me the location of 18, and this will be negative 24 plus 28, which is 4. Okay, which is actually where they would have collided to begin with at 1500 hours. Now I actually have to find a vector between this point and this point. So what I'm going to do now, it doesn't really make any difference which way this goes. I'm just going to say then the vector 23 minus 18 and 16 minus 4. This will give me the vector between the two ships. I just take these coordinates and subtract them. So this is going to give me 5, and this is going to give me 12. And then I have to find its magnitude. Okay, the magnitude of this vector, and then it'll tell me the distance. So this is the square root of 5 squared plus 12 squared, which is the square root of 25 plus 144. And that's going to be the square root of 169. And that should be, ladies and gentlemen, that should be 13, I think. If my math isn't all off, that should be 13 kilometers. And let me make sure of that. just to make sure, because sometimes I second guess myself. And that is correct. That's 13 kilometers away. Okay, so that was the answer for that. It's actually 13 kilometers. We're nearly done. I think this is the last question. All right. The circle shown has a center 0 and a radius of 6. OA is given by this, and OB is given by this. O is this the center point. So they're telling me OB, or OA rather, is 6, 0. So this distance, they're telling me the radius is actually 6. That's what they mean by this right here, from O to A, and that's what OA means. O to B is this way, and they're going to say this is, of course, -6, right? Because we're going in the other direction, but this is still going to be 6, so they're just going to tell me this is -6, so that's all right. Magnitude-wise is the same distance. And OC, okay, we're basically going 5 this way, and √11 right here in this direction is what they're telling me here. Is what all this means. It says find the vector AC. All right, the vector AC is pretty straightforward. I can actually take the coordinate of C and subtract the coordinate of A, and the coordinate of C is OC right here, which is this one, which is 5 √11, and we're going to subtract the coordinate of A, which is 6, 0. So this is going to be 5 minus 6, which is -1, and then this minus 0, which will be √11. So this is actually the coordinate, or the vector, sorry, AC. That's really what that is. Using appropriate scalar product, or otherwise, remember scalar product is also called a dot product, or otherwise find the cosine of this angle OAC. OAC, they want to know the cosine, and I really should erase this part here so we can see this, because I write too much on here. Let's get this pen back. They want, if I add this point here, they want to find OAC. They want to know this angle right here. Okay. So if I want to know this angle, what I really need to find is a vector leaving the angle going to this point and a vector going to this point, which is A. So what I really need is AO and AC. Now luckily for me, AC I already found. This is what they asked me to do, which is nice. AO, though, is the same thing as OA, since I give you OA, but we're going to flip the signs. So this is going to be -6 and 0. So I have a dot product of -6 and 0, and the other one will be -1 and √11. I have to take this dot product. So this will be this times this, top times top, which is 6, plus bottom times bottom, which is 0, which is pretty straightforward there. And this will give me 6. And now to find the cosine of this angle, the cosine, remember your dot product formula, let's write it over here. It's the dot product of A and B is equal to the magnitude of A times the magnitude of B times the cosine of the angle. We just don't know these magnitudes, so we have to find the magnitude of this and the magnitude of this. So we'll square them, add them together, and then take the square root. This one will be 6, and this one right here. We'll square this. Well, if we square √11, we get 11, and then we're going to have 1 added to that, so we're going to have √12 is really what that is. Okay, so that's going to be √12, I believe. So we're going to say then that 6 is equal to 6 times √12 times the cosine of this angle. Okie doke. So what this really means is that the theta angle is equal, well actually I don't want the theta angle, I just want the cosine. We'll say the cosine of theta is equal to 6 over 6 √12, which is actually the same thing as 1 over √12, okay? Which is actually the same thing as √12 over 12. This technically could be your answer. If you left it like that, that would be fine. But if you gave me a decimal, let's see what that turned out to be. I think it's like 0.29 or something. I think that's like 0.29 or something, yeah. So let's do this. Let's just ask the calculator. Make sure. And then this is 12. Yeah, it's like 0.28, 0.29. That was the answer for that. So that'll be 0.29, and that's not the angle, it's the cosine of the angle. I don't want the angle itself, I didn't ask you for that, so be careful. Find the area of the triangle, ABC. Be careful with this one. This one is a pitfall. Let me show you why. Let's get this eraser out again. Alright, the very last question. Find the area of triangle ABC, given your answer in the form of a root 11, where a is a member of the natural numbers here. So basically, you have to be careful with this one because a lot of mistakes on this one I saw. Triangle ABC, that's important to know that. Let's go ahead and connect A, B, and C here. Some people did not use the correct triangle. They went from A to O to C instead of A to B to C. This is what the triangle actually looks like right here. Okay, so we have to find the area of this triangle in this form right here. Okay, the area of a triangle is 1/2 base times height. Okay, if I call this the base right here, this distance here, since the radius of the circle is 6, this distance will be 12, so that would be the base. What I don't really know is this height right here. Okay. But I can actually figure this out because I can figure out this theta angle right here. This theta angle, that's a theta, using this this problem that I just did here. Okay, so let's find theta first. Theta, based on what I see right here, is the cosine inverse of 1/12 of root 12. 1/12 here. So let's actually figure out what theta is first. Use the calculator. Alright, so I go cosine, make a fraction, 1/√12. That angle is about 73.22 degrees. Alright, so we'll say, okay, that's about 73.2 degrees. Give or take, right? That's what that angle is. The height over this distance from A to C, okay, which is the magnitude of this vector right here, which I actually already had defined, okay, is actually root 12, that distance here. So that over root 12 is actually equal to the sine of 73.2 degrees, thereabouts. Okay, about equal to that. So that height can be found as root 12 times the sine of 73.2 degrees. Okay, remember that's approximation there. And then that's what I could plug in for this. So I already know the base is 12. And it's basically times root 12 times the sine of 73.2 degrees. Alright, so let's kind of get an idea of what that is. So we'll say 0.5 times 12 times root 12 times the sine, and we'll just use the previous answer. I'll hit control that, okay, and then I'll hit enter. That's about 19.89 and such. That's the area of the triangle, but they want this in terms of a times root 11. So what I'm going to do is I'm going to take this answer, okay, and I'm going to divide it by root 11. That will give you the value of a, and that value of a is 6. So what I can now say then is that this value of a right here for this answer is actually 6 root 11. That's the answer for this question, and you're done. So this natural number that they ask you for, that's 6. That's really all there is to it, and I hope you look over this and you're doing your test. If you're doing it again, all the answers are here. I just want you to go through it and make sure you understand everything, and then of course submit the retake, and I will give you some points back on your exam. And I wish you the best of luck. This is the end of the school year, so hopefully I'll see some of you next year, and enjoy your summer. Thank you.